Now what I'd like you to do is actually try example 2 and 3 on your own, right? So go ahead and pause your video and just read those and plug those in on your own. You'll notice, right? You'll notice then that this original I colored in this navy, right, has a y-intercept here of -2. Whenever you multiply all your y coordinates by 3, this becomes -6. Versus when you do the same thing, you multiply your y's by 1/2, this becomes -1. Right, so the same thing's going to happen over on this side of the graph and this side of the graph, of course. What's not changing here are your x-intercepts. When you multiply your y coordinates by something, 0 stays 0. So go ahead and do the same thing for example 3. Pause the video and try those. Well, this is a kind of poor depiction, but I was trying to get us to the point, the fact that this 1/3 is actually going to pull it further away from the x-axis because I take my x coordinates and I multiply them by 3, the reciprocal of that scale factor. Versus on this guy, I multiply them by 1/2, they go closer to that y-axis. Again, you notice here, the y-intercept is not changing when you're just multiplying x coordinates. That's what we're going to be using when we're talking about these image points. If I have the following points on a function, if I go by this transformation, if I were to ask you to describe that in words, it's going to have a horizontal stretch with a scale factor of the reciprocal of 3. And it's going to have a vertical stretch with a scale factor of just that raw 4. Now, when we translate this into what do I do with my coordinates, this is going to mean take my x coordinates and multiply them by 1/3. And take my y coordinates and multiply them by 4. That's what we're going to do for each of these points. So when I ask for the transformation, the image point, I'm going to take my x coordinate of 0 and multiply it by 1/3. That's still 0. Take my y coordinate and multiply it by 4. Now we're at 12. Same thing for this point. If this is on the original, when I go to my transformed point, my x coordinate is multiplied by 1/3. My y coordinate is multiplied by 4. And again, if that's my original point, my image multiplied by 1/3, multiplied by 1/3, and my y coordinate is times 4. So that's where my image points are on the graph, not even graphing the whole thing, just grabbing a few points. Then we're going to do a couple examples algebraically like we did on Friday as well. Stretched vertically by a scale factor of 2, right? So the function f of x is done stretched vertically by a scale factor of 2 to get to g of x. So g of x is the transformed function, right? G of x is my transformed function. It's stretched vertically, which means the 2 goes on the outside, 2 times f of x. Right? 2 times f of x, which means, of course, I can take this and plug it in for f of x. 2 times the whole thing. Really, I'm just doubling all of my coefficients in this one. So my final answer is 2x cubed plus 6x squared minus 4x plus 2. That's my final function, g of x equals. The next one, however, we notice is stretched horizontally by a scale factor of 2. So notice again, from f to g, so g equals f of, right, because horizontally is going to go on the inside. Since it says scale factor of 2, I've got to put my 1/2 of x inside, right? Of course, you could call that, if you wanted to, x over 2, won't matter. This one, of course, is going to mean that the 1/2 x goes in everywhere we see an x. Right? So when we expand that, I've got cubed plus 3 something squared minus twice something plus 1. That's where my 1/2 x goes. Don't forget, whenever you cube this, you've got to cube the fraction as well. 1/8 x cubed plus 3 times 1/4, so 3/4 x squared, minus 2 times 1/2 is just minus x and plus 1. So here is your new transformed function taken from f stretched horizontally